Welcome everybody to our follow-up to our previous webinar. This one's all going to be about deep diving into temporal and AI and use cases and all this kind of stuff. I'm joined by our two co-presenters. First up is Josh. Josh Smith is a staff solution architect at Temporal. He helps enterprise financial services and e-commerce teams design and develop resilient, reliable systems. You were a C developer originally. That's old school, and you've done things from leading development teams to architecting things to infrastructure developer operations. So you kind of have a well-rounded knowledge of all kinds of different technical topics. And then Steve is also a senior staff solutions architect at Temporal. You help Netflix, Airbnb, all kinds of folks develop Temporal at scale. You spent 5 years over being a solutions architect at Amazon and AWS as well, and also worked in biomedical research. That's really interesting. Very cool. So thank you so much, everybody. And I'll turn it over to Josh.
All right. So welcome, welcome. Thanks for showing up. This is our agenda for today. We're gonna walk through the architecture of this agentic AI system with Temporal. I'm gonna do a demo of single goal. We got a lot of responses from the last webinar that people wanted some financial services scenarios, so I'll do one of those, and then we'll do some multiple goal demo. Intermixed into that will be overcoming failure. We're gonna have some things maybe break, and we'll see how that goes. Hopefully, a few things break and it all breaks transparently. That's the goal. And then Steve's going to do a code walkthrough. And if time allows, we'll enhance the agent. But we do want to make sure we leave a lot of time for Q&A. So that will be really important. And hopefully you'll have really awesome questions. Just FYI, the recording slide deck and the code repo will be emailed to you after the presentation. So first things first, architecture walkthrough. I like to start high level and then get into the details. So the high level of this system is basically three flows, all orchestrated by a temporal workflow. The first flow is what we call the interaction flow, where the agentic system gets input. In our case, it'll be from a user. That'll be me. And it could also interact with new events or new data and then gets back to the user. The second flow is the decision flow. That is really the brain of this system. It's really cool. The LLM decides on its own what decisions to take. And if it needs more input or what direction to go, it can prompt back to the first interaction flow. But generally, it decides what to do next. And that's fun and exciting to demo. And then there's an action flow. And this one's really important. This is the other piece of what makes a system agentic is that it does things and takes action. And in our system, Temporal is orchestrating all of these, and the flows, the LLM flow and the action flow are done with activities, which makes them very, very durable and reliable, which is pretty cool. So let's dive in a little bit to how the interaction flow works and define some terms. Here is an example interaction flow. It's pretty simple. The user, in this case, picks a goal. The system prepares tools, asks for arguments, gets those arguments, executes the tools, and then, hey, when we're done, let's go back to select goal in a multi-goal system. Important terms here are we've got a user or some sort of input. We've got the system that's made up of AI goals and tools and their definitions there. Let's dive in even deeper and break apart what the system is here. So we've talked about the human that interacts with it. We've got a user interface that you'll see in a second. And then the workflow is doing a lot of orchestration here. It is directing the LLM with prompts saying, hey, we need to go do this goal. You decide how to do it. And also when users give input, that input is validated. And the workflow also orchestrates tools in the action loop. If, for example, the response isn't valid, the LLM will say that to the workflow, and then the workflow will go pass that back to the user and say, hey, I need some valid input. Wanted to get into some of the pieces and what they do here in this architecture. So the workflow, like I said, orchestrates these flows. It uses goals and tools, which Steve will dive into to guide the LLM. User input comes in via signals, and the source of truth of the chat, all of the information, is kept in the workflow, and you can query it out. And I'll show how some of that works. It keeps record of every interaction, which is really nice. You can do analysis on it at the end. You can track it in the UI, and we'll show that. And it handles failures durably, which is really, really cool. Tools are pretty basic. They can really be anything. In Temporal, they're just code, so you can really do whatever you want, and failures are handled gracefully. And hopefully some things will break, and we'll get to show that. Usually in a demo, you don't hope for things to break, but in this one we do, so wish me luck. With the LLM part of the system, it can be really whatever provider you want to use. Today, I'm going to be using OpenAI. It makes me happy, but there are lots of options. And the LLM is really acting on its own. It's validating input, it's driving towards goal selection. It decides what the next step is, and we'll show that when we do the demo. It's picking out what to do next, which is really quite cool. Interaction, like I said, is managed with temporal signals and queries. And what's nice about signals and queries in Temporal is they are just code. It's really easy to add new signals. I did that as I was working on this system. And it lets the input be very dynamic. In our case, it's just me, but you can send whatever information you want to a workflow. And in an agentic case, that can let you do a lot of really interesting things. As long as it's serializable, you can send it to the workflow. So here is an example of doing a whole goal execution cycle with all the pieces put together. And this is an expansion of the earlier diagram that we had. Here, the user, this is multi-goal. So the user picks a goal. And that first block there is the system saying, hey, what goal do you want to do? And then the user says, oh, I want to book a flight, for example. And then it says, okay, we're going to go book a flight. And then we gather the arguments to complete that goal, to book the flight. And we execute all the tools as needed by that goal. And then when it's done, we go back to the user and say, okay, that was cool. We're ready for a new goal to be picked. And these loops, try to put them all linearly here. These loops really give a lot of power and flexibility, and Temporal is great at orchestrating all of these. In this system, it's really nice to be able to use Temporal Cloud. As Angie talked about, we help customers in a lot of different spaces, do a lot of different things with Temporal. And I'll show this, but the UI is really, really nice for tracking the conversation and seeing how it all works together. Temporal Cloud has basically infinite scalability, which is really, really nice when you want to go live with these systems. You don't need to worry about the back end not having enough scale. And we also have really nice security. Sometimes you might be chatting about stuff like, hey, I want to go book a flight, and you don't want everyone to know that you're booking a flight. You want to move money, and you don't want everyone to know that you're booking money. So we have built-in encryption and security, and that is really nice for this kind of system. We take care of a lot of the illities for you, and also performance and low latency. In our architecture, we also have temporal workers running. This worker is running on my laptop. It's going to basically have all of the code that drives the system, and connects out to the LLM. And that's really nice. It gives structure to the application. And another thing that's interesting, we built this in Python, but there is nothing about this system that needs to be Python specific. Temporal supports a lot of languages and SDKs. And it's really cool that I have some customers who are thinking about building this exact system in other languages like Go, which I think is really quite cool. It's also testable because it's just code. So here's the overall diagram of the interaction flow. I thought it was interesting to present it both as sort of like a flow chart, and also as sort of this sort of numbered interaction flow with all of the pieces. The user talks to the UI. There's an API running that talks to Temporal. The worker pulls the work to do, executes the workflow, executes any activities such as to call the LLM. If the LLM is having a bad day or is slow, the activities make sure the LLM is durable and retries automatically. And then the LLM drives towards the goals that are made up of tools, which are also activities. Okay, demo time. Wish me luck. So here we have the agent. This really could be anything, but right now, anything that accepts input and can drive it along, this could be Slack, but we built a simple chatbot UI to demonstrate this system. And this is live. If I go over to my workflows in Temporal, I can see that it's got input and it started and it has planned a tool. And that tool is going to be to figure out, hey, I want to go help you check your account balance. Very simple, single goal. Okay, I'll do that. So I really like the show Daredevil. So I made all of my demo data be characters from the show Daredevil. And if I can type correctly, um, I'll type in my fake user's email address and account number. I also like Fibonacci sequences, so there you go. So now I've given input, and when I go back to my workflow, I can see that I've sent some things to the agent. There's my input, that's a signal, and then it validated that prompt and planned the next tool. The workflow doesn't say, oh, you should do this tool and this tool and this tool, like most temporal workflows. The LLM decided what to do next, which is really quite cool. And in this case, we want to check to make sure my account is valid. It said, okay, let's do that. I get this confirmation box, which is really nice. I can see what it's thinking and what it's trying to do. You don't have to have that confirmation box, but it is nice to be able to see exactly what's going on. I hit confirm. It says, okay, let's go check your account balances. That's what we're here to do. It does that. Yay. These are my account balances for Matt Murdock. Matt doesn't have a lot of money, and that we've accomplished our single goal. So I'm going to go over to my settings, which you can't see because I'm just sharing my screen. And I'm going to change this to be multi-goal. So if you look at the code, all I'm doing is changing um, the agent goal to be choose agent type.
Yeah, and the reason there's an error affecting the conversation is Josh must have stopped the temporal worker
Yeah,
momentarily.
yeah, thank you. I stopped my worker and then I mistyped my environmental settings file and then I started it again. So what's different about this workflow is the first goal isn't a specific goal like account balance or move money or book a flight, but the first goal here is pick which agent to work with. And in our system, when a goal is completed, the system knows, oh, I need to go back to picking a new goal, or at any time the user can say, hey, I want to be done, and I'll stop. So right now it's saying, hey, what do you want to do, user? And if I go over to my new workflow, I can see that it's done a little bit different. And instead of planning a specific tool related to checking account balance, it's done a tool, it's selected list agents. So I'm going to say, yeah, let's list our agents. And these are some of the agents that it can do. Our system has a lot of flexibility. I picked a subcategory of all of the possible goals that you can do with it. And OpenAI really loves numeric lists, so it did a numeric list today. In the guidance I gave it, I said just list them, but it likes numeric lists, so we're doing that. You can type a numeric answer and it'll know what you're talking about, but I'll just say I want to move money. And actually, since we're supposed to demo some failure scenarios too, I'll say, why is the sky blue? And what should happen is the system is smart enough to say, hey, wait a minute, we're here to pick agents, pick goals. Uh, I'm not here to answer questions about the sky, which is great. It did that. If you go over to my workflow again, you can see that it validated that, and it'll say, wait a minute, validation result is false. You're not doing the right thing, human. And so now I have to do what it tells me to do. So I'm going to say money movement, and get back on track. And what's really cool about the validation that Steve did is it really keeps the conversation on track towards the goals. We've had a bunch of people try to break out and they couldn't do it. So, okay. So now we've picked a goal. We're going to do it. And we're going to try and move some money. And the LLM is working us through that process and says, hey, do you want to provide your account number and email address? And I'm going to be Wilson Fisk. If I did happen to typo this, it would validate that and say, oh, that's not right. So it's going to validate my inputs. In a real banking scenario, it would probably already have this. We use this to demo just the interaction and multiple tools towards a goal. But probably if this was really a bank account chat system, it would know what your account ID was. Yay, my account's valid. Oh no, it forgot. So what's really cool about this system is all of the conversation history is kept as part of the temporal workflow. So sometimes the LLM doesn't really think about what it just learned. Sometimes it does. Some models are better at this than others, but since the LLM has the whole conversation history, I can do something like if it forgets a previous piece of information I gave it, I can say, and then we'll send that back to the LM via an activity, and it'll say, "Oh, right, of course, I know who you are." Again, in a real system, you'd probably already have account IDs and all that stuff as part of the session, but it's really nice if you're building tools to do various things that the LLM can sort of look back on the conversation history and figure out what to do. So there we go. I checked my account balances. Now I can figure out how much money I want to move. So I'm going to say I want to move. You can also just say $500 from checking to savings, but I'm going to give it a little bit different input. What's great about the LM is it can process a variety of different ways humans can talk to it and determine intent. So I want to move $5,000 from checking to what would Wilson Fisk want to buy? To buying large cars, fund 7. And it says, hey, that seems kind of important. I want to confirm this. And I'm going to click confirm. And ta-da, it's done. And it's asking me what I want to do next because it knows it completed the goal, which is really, really cool. One thing I want to say is this system is a lot of fun to work with. And I hope, as you're playing around with it, you figure out how goals and tools work and add some of your own. One thing I did want to mention is I'm hoping some of my tools failed and took multiple attempts. Looks like they all succeeded every time, which is a bit of a bummer. So one of the things I did when prepping for this demo is set up all of my tool activity APIs to fail 70 or 30% of the time and succeed only 70% of the time. But every one of them looks like they succeeded on the first try. And I can tell that because all of my temporal attempt counts are 1. So it didn't fail. But in the interest of time, I will keep going because we have a lot of cool stuff to show. But if it had failed, if any of them had failed, or if the LLM started to respond more slowly, Temporal would take care of that for you. The demo gods did not smile on me and did not make things fail how I wanted. So I can pick a new goal. I can pick end chat, but I'm going to stop right now because I'm going to hand it over to Steve to do a walkthrough.
Oh yeah. I was having so much fun answering questions in the chat that I forgot that I'm presenting the next section, but here we go. A good thing I'm prepared. All right, I assume, Josh, do we see like the slide? We good?
Yeah, yeah. I didn't put up code walkthrough, but that is next.
Wonderful. Perfect. We're ready to roll then. Okay, let's get into the code. All right, what I wanted to do is explain to you how to create one of these agents with Temporal. And I was going to do that by iterating with several examples. And so I've got 4 examples, and each example builds on the previous one. And I'm going to enhance capabilities yeah, as we go through each example. So this is a very basic chat loop. This is not an agent. Example 1 is just the simplest of chat loops, and I'm going to point out the salient details of that right now. We have uh, a basic chat loop that takes user prompts and will give LLM responses, and will log both the user prompts and the LLM response to the history. To do this, we have an agent goal workflow. This is using Temporal's Python SDK. And so this is our workflow. And in our workflow, we've got some instance variables here. We're going to keep track of the prompts that come in to the workflow. So this is you chatting to the workflow. And we're also going to keep tabs on the conversation history. So that's bidirectional. That's both things that you send to the workflow, the chats, and also the LLM responses. So that's what we're going to keep tabs on. And the next question you may have is, okay, so how are we going to fill this prompt queue? How are we actually going to interact with this workflow while it runs? If a workflow is a chat session, how are we going to talk to it? And the way to do that is to signal it. So in Temporal, you signal workflows. This is a way of sending information to workflows. You can send an update, a workflow update to a workflow as well. So for those going, why not update? That's okay. We're using signals for this particular example. And the signal handler for user prompt is actually just going to append the prompt to the structure here, this DQ structure up here. Okay. So this is how you talk to the workflow. And what happens is we have this kind of event loop. This is a while true. Anyone who knows code would know usually having a while true and kind of a wait is a terrible idea. But in Temporal, this is actually fantastic. This event loop is going to sit here and it's going to wait forever for the prompt queue to be filled up. And so it's going to sit here until you signal it, basically. That will unblock this condition. We've got something on the queue to deal with. We will pop the queue left, which is basically take the latest prompt off this queue. And then we're going to add that message to the conversation history because we need to, again, record it for later. Then this is the meat of the LLM call. We are going to send that prompt to our favorite LLM, whatever we're using at the time, get a reply from that LLM, which will be just plain text because we're just sending like, hello, how are you? And it might say, hey, I'm great. We're going to take that reply, we're going to annotate it to the conversation history, and then we're golden. We kind of wait for the next prompt. All right. So the pros of this is we have this kind of event loop now, and this is really what makes the agent tick. And it's going to handle multiple prompts. You could prompt this all day. You could keep this workflow open for years. That's fine. It's just going to take more and more prompts and deal with them and then keep appending this history. And a downside to this is there's no persistent context beyond the immediate history. So what I mean by that is if I prompt it, right now I'm just sending the prompt and I'm not actually sending the conversation history to the LLM. And that means it's effectively stateless. We also lack tool planning and execution. This is not an agent because it really is just a chatbot. Like it gives a response. It's not actually planning to do anything. There's no goal in mind. There's no awareness of any tools. So it's kind of dumb in that way. And the workflow never ends on its own. There's actually no mechanism right now in the code to end the workflow. This event loop will continue forever. It will either get prompts or it won't. It'll just run forever. And so that's probably a bad thing as well for a chat session. To bring the stateless nature of the agent to life a little more, I have an example here where I say, hi, my name is Steve. And it says, nice to meet you, Steve. That's the LLM's reply. What can I help you with today? Beautiful. And I said, okay, what's my name? And it says, I don't know your name. Okay, so this is because we're not saving conversation history. Well, we're saving conversation history, but we're not actually passing it through to the LLM each time. There's no context. It's a blank slate every time you message it. So let's fix that. Let's introduce agent functionality. Let's make this LLM aware of an overarching goal and tools it can use to get to that goal. And then let's make sure it can keep tabs of the conversation as we do that. All right, so this is our planning agent. You'll notice I've added quite a lot here. We're going to actually spend quite a bit of time on, in fact, we're going to spend the majority of our time on this step. So don't worry, there's subsequent slides because the planning agent does a lot of heavy lifting. The main thing we've added here is this call to the LLM has changed. We're not just calling an LLM with plain text and getting a response. We are now calling something I've called the agent tool planner. And the difference between the agent tool planner and the LLM call we had before is before we were just sending a prompt without any other context and it was responding, "Hi, my name's Steve." And it says, "Hey, how are you?" Now we send a prompt. We send the conversation history to date, so we're a stateful conversation now. But inside this agent tool planner, we actually have given it the notion of goals to achieve and tools to execute on the way to that goal. And we've also provided a bunch of other stuff that I'll get into in subsequent slides. But you can consider this, some form of intelligent agent now. It has a goal and wants to work towards it. The rest is very similar. We still have an event loop. Okay, this is the same as before, more or less. We do have this new section to handle what comes out of the tool planner. So the tool planner is going to return a few states that I'll get into in subsequent slides. But we now have LLM calls that want to go somewhere, that want to run tools, that want to progress the conversation, and want to do that with a bunch of context. A con to the current approach is we still can't execute tools. So even though I'm handling the response from the agent. What do you want to do? Do you want to ask me questions? Do you want to run tools? Do you think we're done with the conversation? Even though I'm doing all of that, we're actually not. We're not doing anything we're not running any tools. I have no tool calling capability in this yet. That'll be in a subsequent step. And that looks like this. So when you use it in the state that I just showed you, it's going to do this kind of thing. You're going to have a prompt that introduces the goal. And so this is something I seeded. I provided goal information and tool information, which I'll go into in great detail later on, and basically said, "Hey, welcome me and tell me what you can do." And so this is the LLM's first response. And then I answer it. It knows it wants to find an event. And I said, "Melbourne in September sounds awesome." And it says, "Great. Let me search for events in Melbourne during September 2025." So it knows that we're working towards a particular goal, which is finding an event as step one towards an overall goal. And it's said, let me search for events in Melbourne, but it actually has no capability of doing that yet. Like I said, we've got no tools, but hey, it can make a decision to do that. So we've evolved. It's not just basic chat responses now. We're planning towards a goal. And the three states you can return are confirm, which is the planner decided a tool should run and wants to confirm to run that tool. Like you saw the green box that Josh kept hitting for confirm to confirm tool runs. The next one is question, which is I don't have enough information to do anything. I might have a tool that I want to run. I might want to run the find events tool, but I need information. So it says what city and what month. And then the final one is done. When the conversation decides it's done, all it needs to do, and then it'll elect to end the conversation. How this looks in JSON data is I've kind of invented this response format from the LLM, and this is how it is. It's this next question you would recognize from the previous slide. It's got a response, it's got a tool it has in mind. And so if I say Melbourne in September sounds awesome to that question, responding to this question here from the agent, it will say, okay, I'm at confirm stage because I took the information from here. Melbourne in September sounds awesome. And I pre-filled these arguments. So I think I'm ready to run a tool. I know that find events requires these things here, and we're ready to roll. And so if you query the temporal workflow, querying is getting information, state information from a temporal workflow. This is actually the JSON payload that comes back, and this is the payload that powers the UI interface at the moment. So the UI that you see and that Josh demoed is actually powered by data like this. All right, again, to labor over the planning agent a little more because it does a lot of lifting. This is an agent tool planner. It is an activity, a temporal activity, which really just means it's a function call. It's an LLM call. We're sending something off to OpenAI's 4.0 or Claude Sonnet or whatever we've chosen. We have the prompt, for example, how about Melbourne in September? But In addition to that prompt, we are sending off an overwhelming amount of context. And our response is going to come back as a structured JSON format that we asked for. Okay, so this is the agent tool planner. It moves the conversation along. It chooses what to do next. For a little more detail on the context I'm sending a whole bunch of stuff. This is actually me scrolling down on the system prompt or the context that I'm giving to the LLM along with my prompt, the chat message. So you can see there's hundreds of lines of context. I'm sending the agent role. You are an agent. You are here to help. You are here to help with the goal and the tools provided. The conversation history to date. I send an example conversation. I find that the LLMs are much more accurate if there's a sample conversation to go off. So I have an example dialogue between me and the agent about finding events, and it works a lot better that way. I've got tool definitions, which I'll explain later on, but it's basically here are the tools and these are the details you need, like the find events tool. This is the goal. You are going to use tools to the overall goal. For example, you want to find events, search flights, and create an invoice for those flights. This is the overall goal that uses multiple tools. JSON rules, this is stuff about the JSON format to return, and that's how the system, i.e. the workflow, is going to pass what to do next and move the conversation along. And then there's the prompt. There's the actual what I asked for at the given moment. And that's, Melbourne in September, or yes, get me that flight, or I'm flying from Hong Kong, please, or whatever, or these dates. Like this is the actual prompt. So it's like, given all of this, how are you going to respond to this? It makes a decision. So like I said, we have a cool tool planner agent. I think it's cool. And we have an event loop that allows you to progress a conversation with full context now. That's great. But if it wants to find events or book flights or do something meaningful, we can't actually run any tool because I'm actually just passing right now. So let's give our agent the ability to run tools. Okay, so this is the third iteration of 4, and I'll spend much less time here than on the tool planner agent because it's pretty simple. What I've actually done in the IDE here in the code is I've compressed this. So I've just shrunk it. You see line 4 to 7, just to fit on the slide. And this part is what you saw before about the agent tool planner. So this is figure out the next step. And this is the same as before as well. So all of this stuff is the same as before. What I've introduced is this section here, the confirmation step. Now, if the agent tool planner decides the next step must be confirmed, i.e. I have a tool that I'm ready to run, then it will go ahead and execute an activity called run tool. And run tool is going to execute with a tool in mind, for example, find events because it knows about tools, and the arguments. It knows about what arguments satisfy those tools because it's all in the agent tool planner context, and it's ready to run that. And when it runs that and has the result, it's actually going to append that to the conversation history as well. So the conversation history doesn't just have chat messages and chat responses, it has tool results as well. It wants to know the full detail about what came back. And this tool probably returns JSON data, right? No matter what you run, it's probably an API call with JSON structured results coming back. Right, so that's the agent tool running step. The pros of that is now we have real utility. Previously, we were just planning towards goals we could never reach because we could never run tools. We were just passing. Now with this step, we're actually running tools. By the way, this is a dynamic activity in Temporal. Run tool won't show up in the event history as run tool. So let's say the tool was find events. This dynamic activity, when it calls out to run it, I have a thing that basically sets the name of this activity to whatever tool we're running. So in the event history, you'll see find events or some tool name because it's a dynamic activity. You won't see the generic run tool, but just know that whatever tool it is, we're running it. The downside to what we have so far is it's a runaway train, as I like to think of it. Tools can run without explicit user approval. Because there's no confirmation step, if Josh is doing money movement like he was kind of before, there's this current iteration has no confirmation. So it may just go ahead, validate your account details, decide on amount of money to send, and without asking you whether to confirm, it'll just go and do it. When I had this step in without the confirmation step, and I was doing flight bookings and event finding, it was kind of amazing and also terrifying because I searched for an event in Melbourne in September. It found an event, and then it decided on its own to go and find flights, and then it found those flights without confirming those details with me, and then it invoiced me for that flight booking. Like Like it went and ran 3 tools in a row without confirmation. And again, it was kind of a neat trick. It is kind of cool to have that agent roll on its own. And if you're doing low stakes things, that's great. You probably don't need to confirm. But a major benefit to Temporal here is this human in the loop capability where we can now confirm things. Such a major downside to the current slide. We have no confirmation step. So let's build it. Let's add it. What it looks like today is great. Let me search for events in Melbourne, and then it just runs the tool. Okay, and then comes back with the result. One more thing to point out before I add confirmation is that you'll notice that the data that came back here is actually text. It's a neatly formatted chat message, and it also wants to move the conversation forward. Something I neglected to mention before is this find events tool that runs, it returns JSON data, but of course we don't want to return that to the user. So we actually send that stuff back through the LLM and we say, given this tool result, can you pass this information and then bring out the salient details, summarize some events that you found, and then I'll move the conversation along just like we want you to. So which city would you be flying from to get to any of these events? Okay. So moving on. MCP. So many people are asking about MCP that I better address it. This whole workflow, this whole kind of strategy can be used to call MCP tools. It is not in the demo yet. It will be in the demo. I have an event with Stripe in collaboration with Stripe that I'm doing, and I think I'm going to do agents that can call MCP tools in the Stripe's kind of MCP server. Until then, we don't have it. But let me talk about how it would happen. If you were supporting MCP, one of the things you would do in your workflow when the workflow starts is you would list the tools on one or many servers that you've configured. You'd say, what tools do you have in the toolbox today? So it's a dynamic thing. It reaches out to the MCP server, it gets a list of tools, the metadata for those tools, etc., etc. That is your context. And then when it comes time to run the tool, you would have an MCP tool caller function and you'd be ready to roll. Hey, if someone wants to take Josh and my demo here and build MCP functionality and send me a PR, you would be saving me a bunch of time. But rest assured, if you're not that keen, I will be doing this sometime in May and we'll be able to do MCP tool calling. Okay, human in the loop confirmation. I won't spend too much time on this one, but temporal is really good for human in the loop kind of confirmation or approval scenarios. So let's explain what's happening here. Again, we have our agent tool planner. This decides what the next step is. The next step is going to be question, confirm, or done, just like before, nothing has changed. This tool calling, nothing has changed about the actual, how the tool is called and how the arguments are provided. None of this is different. What is different is some of the new conditionals. So let's expand this. What we have now is some new functionality. We are not just waiting for prompts anymore. We are waiting for either prompts to come in, a user prompt to come in, or we're waiting for a confirmation. So waiting for Josh to hit the green confirm button, like in his demo, for example. And we will accept either of those things. And if a confirm signal comes through to the workflow, it will unblock, it will go to this section here, and it will figure out if we're waiting for confirmation at all. Okay, so something I'm not showing in the tool planner right now is there is some logic that says, hey, if there's a tool to run, set this essentially this boolean that says we are waiting for confirm because we don't want to send or we don't want to handle confirmations unless we're waiting for a tool run, right? It needs to be in context. And so if we're waiting for confirmation and we're handling a confirm signal, which we've introduced down here, by the way, and we've just flipped a bit to true, right? We've just flipped a instance variable to true. If that signal comes in, we're unblocking this and we're going straight here. And if we're running and waiting for confirmation, we will now run the tool. So now we have human in the loop confirmation capability. And that's a very good thing, I think, if you're transferring money or booking flights or doing something with stakes. The actual real the real agent demo that we have does this in a bit of a smarter way. We have conditional confirms based on the tool. So some tools you really want to confirm, and some tools aren't important enough to have this kind of human in the loop confirm step. And you can define tools that require confirmation and ones that don't. So of course you can kind of code that as well. And we built that into our demo. Great. So that's the user confirmation step. One more thing about that is it's pretty cool. Something I think is pretty cool, and it was kind of unintended when I was originally building this, and then I kept it. let's say we have this confirm step. We want to confirm running of find events. Okay, it knows it wants to run this. It's got the arguments. Let's run it. Let's go confirm. What if I change my mind? What if I want to do events in October or I want to do events in Sydney or something like that? Well, because we're waiting for either a prompt or a confirmation signal, I can actually just go and type this message and say, well, actually, I meant October. Actually, I meant Sydney in October. And this will just go away. The LLM will chew on it, and then the LLM will come back with another tool proposal and say, hey, agent is ready to run find events with the new details you provided it. So you can kind of see this and go, actually, I don't want to do this yet, and then change the story and get a new confirmation. And I think that's really cool. I think that's what users in real life will really want to do. And again, in Temporal, it's done in all the code you saw above, which is not many lines of code for such sophisticated event handling kind of capabilities. Yeah, and then we run the tool. We have an AI agent. It's Josh enhanced the current agent demo to do a bunch of multi-agent things. So technically, the current agent can handle multiple goals, and that's outside the scope of this. Like the code, I feel like the code walkthrough had enough in it, so we didn't cover that. Maybe that could be a future webinar if people are keen, along with maybe MCP and Nexus. There's a bunch of stuff we want to do. But this is an AI agent. It's a single goal AI agent that can use multiple tools towards a goal. It has human in the loop confirmation. And as you can see, I've compressed some of this code here, but it really is like, we're talking about 53 lines of code of Python code. And I think that's pretty powerful. So I think Temporal is a great production at scale AI kind of system. We were going to enhance the agent to add a tool live, and I thought maybe we would run out of time, and I think we will here to add a sort of a new capability to the agent live and in the room. What I want to do instead is I want to explain to you how goals and tools are fed to the agent and how the agent is dynamically able to handle multiple goals and different tools. And then I want to turn this over to Q&A. I want to make sure we have about 10 minutes for that. The agent workflow is dynamic. And what I mean by that is it accepts goal definitions and it accepts tool definitions as input. It doesn't, the workflow itself doesn't have any idea. The workflow code itself, the code you've been looking at, doesn't actually have any concept of what goal or tools it should run. It's a completely generic agent. I could have fed it any goal or any tools. And I think that's actually a massive strength. And so the question becomes, well, how are we feeding goals and tools dynamically to the workflow? And the way we're doing it is through workflow input. When we start a workflow, which is a chat session, we feed it a goal definition and we feed it a series of tool definitions. Now, this stuff is just structured Python that we deserialize to JSON. There's nothing special about these goal definitions. It really is something for the tool planner just to chew on, and it doesn't follow any set format. In other words, I just made it up. But let's say we were feeding a goal definition with a description, your job is to initiate a money movement order, and you're going to use these tools to get to that goal. Oh, and by the way, the tools are defined like this, and each tool does this, this, and this. The sum of information, a goal or many goals, and a list of tools it can use to get to this goal, comes in as workflow input and then is fed to the agent tool planner. So if I say $10 to Josh, thanks, as my prompt, it uses this goal definition and tool definition in the agent tool planner to know what this means in context. And it has the conversation history, of course, because $10 to Josh, thanks, is probably not enough context to go and do something. So let's say we've had a conversation with $10 to Josh. We know what we're doing, which is money movement. We know we have these tools on hand, and then we're ready to run a tool. So the agent tool planner goes, okay, we can run a tool. Let's execute. Now, you will have noticed that the available tools here are actually part of the code base. I am not making up AI, API calls. Like, I am not making up Stripe invoice creation calls. I actually have pre-built functions, pre-built tools that will generate a Stripe interface or a Stripe invoice with the relevant keys in it and that kind of thing. This stuff is predetermined. It's a tool library, right? And these are the definitions about how to run those tools. Now, this could be easily replaced with MCP tool calls, and therefore it would live somewhere else. And so you'd just be reaching out, and that's the next major move for this demo. But just know now that there is kind of the concept of having a tool library, and that's currently in the code base. And so if you'd add your own tools, and if I had time to show you that, which I don't think I do because I want to get through to Q&A, what I would do is I would create a new goal definition that says, hey, I want to I don't know, I want to buy an ice cream, and you're going to have a tool that shows me what ice creams are available, and you're going to have a tool that allows me to elect to buy an ice cream, and you're going to have a payment thing to charge me for an ice cream, and that's going to be wonderful. And it's going to come in as workflow input, but crucially, I'm going to have tools that can contact the ice cream API and tell me about an individual ice cream, right? And then do some payment for that. And so these are the tools that I would pre-seed. And again, that's going to be MCP in the future, but haven't had time to build it out just yet. So hopefully this demystifies some of how agents work and how agents work with Temporal. Let's get to Q&A. I believe Angie has another poll that I'm not sure we wanted to run or not. But either way, I'd love to turn it over to you folks for all kinds of questions, and I'd love to answer any questions with Josh live.
Yeah, I'll go ahead and launch the poll because this is more information. This is really helpful information for us to know how to, run webinars that are of interest to you in the future, write tutorials and code samples and stuff that you'd like to see. So this set of questions is more around the AI use cases that you're using AI with, and also what is the most annoying thing about AI? Not that there's any of that, but if you have any of those, feel free to answer the question. So in the meantime, so you answered MCP already. That was definitely a hot topic during the chat. I think another big area, maybe you could just talk a little bit in general. So you mentioned MCP is one future direction of this demo framework thing. What are other future directions? You mentioned Nexus possibly, that kind of thing. Where else in your mind are you taking it, and or where are PRs welcome?
I've just talked a lot, and Josh is kind of the visionary, in my opinion, in many ways. And so, do you want to take this, Josh? I'm putting you on the spot.
Yeah, I can try. I was really excited to make this thing multi-goal and sort of keep going with the conversation and be and play with the flexibility of it. And that was a ton of fun. Like, if you take one thing away from this, please try this out, play around with it. You can run it all locally. You just need an LLM API key, and we won't make any money on it. And I promise you, it'll be cool to explore. I did that. I had a ton of fun. I don't have any future plans. I think it would be really cool if Steve adds MCP. I think it would be wonderful to see other people adding to it. I would love to see more goals and tools and scenarios built in. Um, and I think there's the AI space is moving so fast. I want to take a moment and breathe and figure out where we should go with this and what we want to do differently. That's my answer. I wish I had all of my free time to work on this, but I don't. This is not even my day job. So
Yeah,
Totally fair.
I built this stuff on the weekends. Oh, one thing I will add to this as a future capability, and it might not be this demo, but not all agents are chats. Like chats are the first thing that people think about often with agents because it makes a lot of sense that you're having a conversation and getting things done. But Temporal's really good at scheduled runs of things or just watching for events. And so I have this idea where we could have like a living agent. I mean, temporal workflows can live infinitely. That's one of
yeah.
their superpowers. And so what if you had this kind of agent that acted on its own and went and grabbed Salesforce data and then summarized it and grabbed call recordings from an internal like repo or someone's Notion or Slack and then synthesized all this information, decided it was important enough to bother a salesperson or someone about in a company, and then just do that on its own, like essentially make its own decisions, but in a way that's not prompted necessarily by a human. It just goes and refreshes new data or is triggered by, the advent of new data. I think that's something we haven't explored enough yet, but is somewhere where Temporal will just absolutely shine. Either that and or we'll create Skynet and the world will end, but either way, it'll be fun.
All right, so global domination via Steve and Josh's weekend project. Cool.
Yes.
That's great. All right. Another really big topic that came up is between curiosity and alarm. It's the idea of like scaling this thing up. So this is really great as a demo, but there are a lot of questions around like will the workflow history go bananas? How would you go about running this like if this was a customer facing thing and it's having millions of people like what would you do to scale this thing out in the future?
Yeah, there's a couple of like I want to be fully transparent about where temporal rocks and where it needs work or you need to do some extra engineering, particularly with the demo that we just showed. So the demo we showed is it stores all the conversation in the event history and all the tool results in the event history, and that's not the most efficient thing to do. The event history is not really made to store like conversational data long term. It's just not. And the way you'd really do that is like having pointer references. So basically having a reference to a Redis key or an S3 key, and you'd store that information somewhere else. And then for the chat interface, you'd probably also have that reach out to that store. You know, something that's really made for large amounts of data. And all you'd be storing in the temporal event history is references. And so that's one thing. And then the second thing I can think of is streaming. Like when you talk to ChatGPT, for example, the tokens appear as they come out, which is huge and amazing. Temporal, its interface right now, or its APIs are all gRPC non-streaming. Okay, and so we've been talking a lot internally. There's no promises yet about, well, how could we give streaming capability out of the box to Temporal? So if you want to stream tokens or, you know, words on the page, essentially as the AI produces them, you can do that. Because right now, you'll notice when Josh demoed the agent, the responses came back in blobs. You'd get a whole message at a time, and that's fine depending on how long it takes to produce. But sometimes you want to stream things as they come, particularly for longer responses.
But things you wouldn't have to do to run this in production is worry about like temporal cloud scalability, or you just have to have the number of workers you would need. Temporal scales really well that way. So there's a lot taken care of for you,
Yeah.
you
Oh,
know.
yeah. I started with the negative answer, which is a
Yeah.
totally me thing to do. But like, aside from those two things, like this is the agent demo as we have it, like can scale to like infinite users as long as you can pay the AWS bills on your side for workers or wherever you're hosting them. The amount of
Yeah.
Kubernetes pods you need to handle these, and obviously the cost of the LLM calls. But yeah, like there's no inherent constraint on scale,
Yeah.
even in the demo we produced.
Yeah. Don't forget, like there are a lot of things taken care of for you. Um,
Yes.
can I ask a question
Yes,
from
please.
chat? Like there's a lot of really good questions. We were unable to get through all of them. Um, But one of the ones I wanted to ask was about, I'm not put Steve on the spot since he put me on the spot. How would you think about long running workflows and versioning with this system? And if you don't, if that totally bounces off your brain, I can answer.
Yeah, I think one of the most difficult things about temporal is getting your head around the determinism requirement initially, and it's not an insurmountable problem. Like it's a very logical problem. You just need to learn how to handle it. And so what I would do is make sure that we patch you patch your workflows. So if we did have this Skynet workflow that goes and does things on its own and runs forever, what you would want to do is implement Temporal's versioning features to make sure that any new capability you gave are going to be determinism safe. You would determine that by replay testing those workflows. There's a testing called replay testing where you can throw an old history or a current history against a new set of workflow code and basically say, does this fall over in with determinism problems? Like, have I accounted for the determinism requirements of temporal? And the other thing I would do is a neat trick is continue as new like every 24 hours or on a cadence. Continue as new is a way of essentially refreshing your workflow. It's like a new chapter in the same book. You create a new chapter of your workflow run by continuing as new. You carry the state over, and you can continue as new into a new workflow execution and sort of get around determinism that way. It's sort of a longer topic. Maybe I missed something, Josh, but it's definitely
No,
its own topic. But yeah, those are my
that was
strategies.
that was great. One flavor to the questions were, because everything changes so fast with how we want to build our agents, we would have to version or patch all the time. And I wanted to
Yeah.
say in this system, the workflow is actually remarkably consistent. Other than changing it to be multi-agent, the workflow doesn't really change. The prompts change, the workflow inputs change, the tools change, but all of those are not subject to determinism requirements. Those are just workflow inputs and activities. So you can get a ton of dynamic behavior out of this without having to change a line of workflow code. And please check that out. And if you find out that I'm a liar, go find me on community Slack and tag me and be like, Josh was a big fat liar. Because I promise you, the system is really good at managing all of those things without having to change workflow code. It's super dynamic what we built.
If there's one thing I know about Josh, it's definitely that he's a big liar. I'm just kidding. Yeah. One other kind of cluster of questions was around, like you mentioned, things that Temporal is really good at and what it does. There were some questions around like Temporal vis-a-vis alternatives that people, especially coming from AI, might be more familiar with. So Langgraph was mentioned, Crew AI, and there were some questions kind of around like Not necessarily how does temporal compare and contrast, although if you have thoughts about that as well, that'd be great. But also like, what does temporal have for like primitives that would be correlating to these systems? So the task queues was mentioned and maybe some agent specific things. So if you could just talk about that general cluster of temporal and these other like, tools that position themselves as AI workflow tools more, just how does that match up?
I'm going to be very generic with my answer, and then Josh can be more specific. The one thing, if you want, otherwise I can. I just saw his face. The one thing is, we do. It might be nice for us to have even like a community contributed list of components. So something like LangChain, for example, has a bunch of components that you can just get for free, and that does give people a head start for calling LLMs using vector stores and stuff. Temporal is not an AI solution 100%, 100%. Like it's great for AI, but we do a bunch of stuff. And so we haven't done those AI specific components yet. So that's one point of difference where maybe it is a little more work to get started. But in the other column, what I would say, in the pro column for Temporal, what I would say is find me another agent framework that has our delightful developer experience, so code first that you saw, while also being able to run in production at scale. Those are the two requirements. You will find ones that run in production at scale but have a terrible developer experience. You will find ones that have a good developer experience but don't run in production at scale. I think Temporal is perhaps the only thing that can do both right now. That's my big claim.
Yeah, and I'm gonna say, oh no, we're out of time, and I don't want to get into these specific details. There, my real serious answer, there are a lot of really awesome tools in this space. I think Steve's answer is 100% correct. I am certainly a very biased pro temporal person. I love the developer experience. I love the visibility. I love the testability. I love that I can write everything as code. I'm a programmer at heart. And some of these other tools, they make my head hurt a little bit. But they're also really, really powerful. And we see people mashing them together, temporal and these other tools, in lots of interesting ways. And we'd love to keep talking about that. I'll try to keep it short.
Okay. We are at time, so I want to end this on time. The 100% most often asked question is, can we get a recording of this? And yes, you can. That will be sent out an email after we get a chance to compile some stuff. I'm also going to post the Q&A to the forum, so watch for that. That will also be mentioned in the email. And I just want to thank everyone. Thank you for coming. Josh, Steve, you did an amazing job. Thank you, Anthony, Dallas, Donald, all you people that were helping answer questions in the chat, as well as the attendees who helped answer questions in the chat. Thank you so much. This was great, and we'll see you in the next one. Thank you so much.
Thank you.